Hi everybody, I want to do another video in the carpentry and joinery course. We're going to be talking today about setting out a staircase. Now there are a number of certain things that we need to be knowing about, certain details that we need to obtain before we set out a staircase. We need to know, for example, the overall the overall headroom height between the finished floor level at the bottom of the stairs and the bulkheads. So anything that's above your head needs to be at least 2 meters. Okay. And we also need to know what the height is on the landing between the finished floor level of the landing and the ceiling, and that also needs to be 2 meters. Now there's two other measurements that we really need to do, and they need to be taken very accurately, and that's the overall rise of the flight. That's from the finished floor level at the bottom to the finished floor level on the landing. We use the word landing because we're talking about flight here. This is the action of the body going from one level to another. The overall going is the level that is from the front of the riser, which will be attached to a trimmer, and the front of the last riser at the bottom of the stairs. Now we need to know what is the overall going. Going means the distance horizontal, whereas rise is the distance vertical. Those are the two major measurements that we need to do. Now, the stair regulations are very important for us to understand as joiners, and these are contained in the building regulations where it applies to staircases. The construction and design of stairs is controlled under the building regulations, an approved document, which is Part K. There are a number of categories of stairs. We've got private, which are installed in people's personal houses. There's general access, where a number of people will gather, for example, in a public building. And then there is utility, which are flights in all other buildings, also known as common stairs, as they are used by more than one dwelling, for example, like in flats. In flats, you have lots of dwellings and you have the common stairs. Now, the details of the regulations, I'm going to describe pretty well most of it just now, but this is something that you really need to get hold of yourself. Get hold of a copy of the Building Regulations Part K and keep it in your filing cabinet so that you can always refer to it when you need to. The first thing we need to remember is we've got these three types of staircases. We've got the private, the general access, and then utility. Okay. Now, the minimum rise on private stairs is 150, and that's the same for general access and utility stairs. So the amount of the height of a step should be no more than 150 on any staircase. But that's the minimum rise. The maximum rise, okay, can be no more than 220 on private, 170 on general access, and 190 on utility stairs. So that's the great thing. It's very important. The minimum is going to be 6 inches or 150, but the maximum may be different measurements. The minimum going, that is the minimum distance horizontally, the minimum is going to be 220 in private, 250 in general access, and also 250 in utility staircases. The maximum going, that is the maximum distance, is normally 300 millimeters for private, 400 for utility and general access staircases. So these are the actual numbers that we need to know about. I don't know whether you're like me, it's pretty difficult to remember just a random number, unless of course you keep repeating it and learning it by rote. The application of rise and going. For dwellings for external tapered steps and stairs that are part of the building, the going for each step should be a minimum of 280 millimeters. The maximum pitch for a private staircase is 42 degrees. Got that? This is the number that you really need to remember. It's as Monty Python said, it's the secret of life, 42. So you need to remember the maximum pitch for the private stairs is 42 degrees. For school buildings, the preferred going is 280 and the rise 150. For existing buildings, the dimensions shown above should be followed unless, due to the size on site, they're not possible. An alternative method should be discussed with the building control and particular attention paid to disabled access. This is approved document part M. Now, the handrail heights for flights and landings, they must be between 900 and 1100 millimeters, measured from the pitch line or from the floor. Now, the pitch line is a line that's taken across not the nosings of the staircase, but across the place where the where the riser and the tread meet. So imagine a piece of timber being put across that. Well, the underneath of that timber would be the pitch line. Now, handrails can form the top of the guarding if the heights can be matched. If the stairs are 1 meter wide or wider, the handrail must be provided on both sides of the staircase, and continuous handrails must be provided on both sides of flights and landings to buildings other than personal dwellings. So you'll notice when you go into a public building, you'll see that the handrail is a continuous handrail going all the way up. It doesn't really stop. It has to be continuous. Guarding for stairs in the form of a wall screen or a balustrade. When there is a drop of more than 600 millimeters, the guarding height for the landing is between 900 and 1100. However, when there are more than 2 risers, then the guarding height for landings will be 1100 millimeters. And where there are more than 2 risers, the guarding height for the landings will be 1100 millimeters. So as you can see, the general access stairs and utility stairs are nearly always the same. They're very similar numbers. Guarding should be provided in all buildings. Okay, in buildings likely to be used by children under 5 years of age, which would be a normal house, the guarding should be designed so that a 100 millimeter sphere will not pass but through any opening in the guarding. This is because children in the past would play about on the stairs and they would get their head stuck between the balusters, and then they would get in a very severe difficulty. They could even die if they slipped. Children must not readily be able to climb the guarding. So the guardings need to be fairly smooth. We don't want to have it in such a way that it's like a ladder going up. The minimum headroom height on all staircases is 2 meters. That goes without saying on all types of staircases. There is no minimum width of stair in a private house unless it is used as a fire escape or used for disabled access, and then it must be at least 1 meter wide. For all other flights on general access and utility stairs, the flights of stairs that are not used as a fire escape must be at least 1 meter 200 millimeters wide, with a minimum width of 1 meter between the handrails, not between the strings, but between the handrails. So as I said a moment ago, the building regulations part K state that the steps for straight flights should have the same rise and going. It's completely out of this world that you'd have a step that's different sizes and then suddenly one will be a different size. Now in France and other parts, I've been to France and built staircases there. They don't have this rule, and you can be coming down a staircase 6 inches, and then have a 2-inch step. And that, of course, is not allowed in the UK. If ever you've done or walked down steps like that, you discover that on the last step, you just stumble because your body hasn't got used to the fact that the staircase rises can be different. And they also state the relationship between the rise and the going shall be twice the rise plus the going, which gives a figure between 550 millimeters and 700 millimeters. So this is like a check to make sure that the staircase follows the rules. The minimum headroom height can be relaxed in some situations, like in loft conversions, where a clear headroom height can be deemed to be unsatisfactory if it measures 1.9 meters at the center of the stair width, reducing to 1.8 at the side of the stair. It also states that all flights of stairs should have a handrail on at least one side if they are less than 1 meter wide. If they're wider, then they should have a handrail on both sides. Some of the details I'm giving you here have been repeated a couple of times. Now, when you're setting out a staircase, as a rule of thumb, a standard staircase has 12 steps. I think when you get beyond 12 steps, unless I'm mistaken about this, when you get beyond 12 steps, it becomes a requirement to have a landing so that you can rest your body before you then go up again. So a standard staircase has 12 threads, and this is a good place to start when designing a staircase. If the total going of a staircase is 3 meters, then dividing this equally will give a going of 250 millimeters for each step. You see how easy that is to work out. Now, the same goes for the rise, the overall rise. We need to remember that when we're working out the overall rise, that we just have to divide it by the number of steps. It's a very simple thing, really. And then we go through this process of checking the process, the little formula I gave a moment ago, which is twice the rise plus the going must be between 550 and 700. That is actually the thing that really will need to have to be remembered. Okay, twice the rise plus the going must be between 550 and 700. And you can check this out on the stairs at home. You can check this out in lots of different places, and you'll find that unless the staircases are incorrect, they will follow that rule. Now, there are two main ways to actually set out a staircase, but although I say that there are two main ways, they're actually the same way. They're just using different instruments. The first one is the template method. So we get hold of a string and we produce a margin. Now, the margin up the side of a string is a line between about, say, 25 and 50 millimeters above the steps. Okay, but it isn't just above the step, it's above the place where the riser and the tread meet. That's the thing we need to focus on, not the front of the nosing on the stairs. The nosing is that little bit that sticks out at the front of a staircase. We ignore that part. We're talking about where the tread and the riser meet. That's actually the point that we want to identify. And what people normally do, what a lot of people do, is they'll produce what's called a pitchboard. Now, a pitchboard is simply a triangle, and it is the shape, okay, of the difference between a riser and a tread, okay? And what you can do then is you can put this pitchboard on your string, on that pitch line, and you can draw the lines with a pencil very finely, very accurately. So that's a very easy way of being able to draw the steps going up a staircase. There are other ways of doing it. One is using, for example, a building square. Now, or a roofing square. Sometimes it's called a roofing square, but it can easily be called a stair square. So this is a large piece of steel, and it has a piece of wood, two pieces of wood put across it where they can be just adjusted. And of course, this piece of wood can be moved up and down the square to get different pitches. What you're doing basically with that roofing square is you're actually just creating a pitchboard. That's very simple, isn't it, really? And what we can do with this is we can take the pitchboard and we can slide it up the string, and we'll find that we can find all the risers, and of course underneath we'll find all the treads as they meet, as they go up the string. I prefer to use a roofing square. That's my preferred method. We need to remember, of course, that on a staircase there's always two strings and they're always in pairs. So for example, if you can imagine that's your stair, as you open the pairs of strings out and bring them together, you'll find that what's drawn on them will be a complete opposite of one another. And the great thing about producing a staircase is that we need to be very, very accurate in the way in which we draw these very fine lines. They need to be able to be seen, but they need to be very accurately and purposefully drawn out. Okay, the string at the bottom or at the top will fit into the large newel post, and it'll come in at an angle, and it'll be a tusk tenon. So it'll be a piece that comes down, then it goes back in again, and it comes down again. The reason for that is if we take a large mortise out of the newel post, it tends to weaken the post. So by leaving a tusk inside, leaving a part of the timber inside, it knits the newel together in the center of the mortise, and of course they're then fixed together with each other by draw bolts or by draw dowels. So these are the basic details about making a stair. They're obviously much better to be seen than described, as I'm trying to do today, but it's a fascinating subject, and if you're able to get your head around how you make staircases, then it will be a tremendous asset to those of you that are going to do site work. It's not necessary actually as a site person to be able to make a stair. However, if as a site person you do make a staircase, then it gives you tremendous insight into what's involved, especially when you get to the top of a stair and then it has to then either go forward onto a landing and then go back up again, or whether it has to go around on kite steps. Kite steps, you know what a kite is. A kite is a sort of it's a thing that you have in the wind, but that shape of the kite is what some of the steps will look like as they go around a corner at a particular height up the stairs. So there we are, that's staircases. Let's talk now about units. We could think about kitchen units, or we could think about other units. But there are a number of different types of units. Let's just list them. There's 5 here. There's bespoke kitchen units. Now, I used to work for a company many years ago, and our speciality was bespoke kitchen units. In other words, they were made to measure. They weren't just 1,000 millimeters. They were 852 millimeters, exactly right, to fit the building. And that was our speciality, that we had staircases of exact sizes. Sorry, we had kitchen units that were made of specific sizes. And then of course there's vanity units, there's library fittings, there's reception counters, and there's bedroom units. Now all of these things, they're all units. They're all cupboards effectively, and there's 2 main ways in which they're constructed. They're either constructed as frames, pieces of timber that are all jointed together, and then a panel's put into them, or they're created from panels themselves. And the traditional way is a framed unit, but the modern way is panel construction. All the kitchens I ever made and fitted in my career in kitchen manufacture were panel construction. There's lots of ways in which the panels can be attached to one another. They could be used with biscuits, they could have corner joints with dowels, they could have studs and cams. I mean, these are just words that you may not know what they mean. The stud is something that comes into a timber, and a cam is something that turns around and captures the end of that pin. Now, I didn't use any of those methods. I used what they call modesty blocks. These were little tiny blocks. They're about that big, and you have 2 screws going one way and 1 screw going the other way, and they were invented really for young ladies who had panels fitted on the front of their desks just for their own personal modesty. Now these can be purchased in their millions and they always use exactly the same screw, which is a number 7, a 1-inch number 7, or 25 millimeter number 7. Number 7 is always the gauge or the thickness of the screw. And with those modesty blocks, it's possible to build everything. everything can be made with Modesty blocks. So the other thing about kitchen units, or units in general, or library units, or any other thing, is that very often they will need to have drawers. There's two different ways of making drawers. The one is the traditional way, in which you have, dovetail joints, and you have a base that's tapered in and so on. These are just very old-fashioned and traditional. The modern way to make housed construction is simply to have boards which are housed into one another at the front and which are housed in at the back. Again, they're much easier to actually talk about than much easier to see than to talk about. Just a little point about the setting out of dovetails. There's 3 different pitches for dovetails. If your timber is going to be softwood, then a 1:6 is a perfectly correct pitch for a dovetail. If it's hardwoods or softwoods, one or the other, then a 1:7 is good. And if it's hardwoods only, then 1:8 is good. So you just measure 8 inches and 1 inch up, and that gives you the angle, or 8 centimeters and 1 centimeter up. All these things are just the same overall ratio. So the one that I use, generally speaking, is 1:7. Doesn't matter, of course, because it does for everything when you're doing dovetails. Now, there are ironmongery for units, for kitchen units or whatever. Lots of different types of ironmongery. For example, we have the ordinary humble butt hinge. We all know what that is. Sometimes we have special concealed hinges, and sometimes amongst the concealed hinges we have special hinges for kitchen doors, which are attached to the door by a circular cut and attached to the frame by 2 circular special fittings. What these do is they like that, of course, when they're in, they collapse into one another, and by collapsing into one another, so the door fits beautifully. And it's a little bit of a knack to sort of get used to using them, but they are superb when you do get use them. Then, of course, there's handles and knobs, because all doors and drawers need to be opened. There can be a straight cupboard lock. Okay, a straight cupboard lock. These are very, very common and fitted onto cabinets. Sometimes it's known as a cabinet lock. That's it, it's a cabinet lock. And then there's the cabinet latch. Now, the cabinet latch is not as commonly used, but it's a little thing whereby you turn the knob and it just opens, but when you push it, it will just click. It's a latch. So because it's a latch, it will actually close automatically when you push it. And then we have drawer runners. Now, these drawer runners are made of metal, and they follow little ball bearings, and they have various features so that when you pull it out, it comes out really nice and smoothly and goes back in. And sometimes you have them made in such a way that you just push them and they will actually slow themselves down and then just silently close. So there's a little bit of an outline for you on all of the things involved with staircases and with units, making units. I wish you well, and we'll catch up with you on the next video. See you for now. Bye bye.